Implementation of DJI's AI-driven flight systems by Q1 2026. Overview. DJI, a leader in drone technology, is set to revolutionize its operations with the implementation of AI-driven flight systems by the first quarter of 2026. This ambitious plan encompasses 4 distinct phases and is backed by a budget allocation of $5 million. The primary goal of this initiative is to enhance autonomous navigation capabilities across 3 critical sectors: cinematography, agriculture, and disaster management. Phase breakdown. Phase 1, Research and Development (R&D). The first phase, which began in Q1 2024, focuses on the research and development of advanced AI algorithms aimed at improving flight navigation and object recognition. By leveraging machine learning techniques, DJI intends to create models that can adapt dynamically to varying environmental conditions and operational challenges. This phase will involve algorithm development, creating and refining algorithms that enhance the drone's ability to navigate complex environments and recognize objects with high accuracy. Environmental adaptation, testing these algorithms under different weather and terrain conditions to ensure reliability. Phase 2, Prototyping. The second phase is scheduled for Q2 2025, where the focus will shift to prototyping. Here, DJI will integrate the developed AI systems into its existing drone technologies. Key activities will include prototype creation, building initial models of drones equipped with the new AI systems. User feedback, engaging with potential end users in cinematography, agriculture, and disaster management to gather feedback on the prototypes. This input will be crucial for refining the systems to meet sector-specific needs. Phase 3, Testing and Validation. In Q4 2025, DJI will embark on the third phase, which involves rigorous testing and validation of the AI systems. This phase is critical to ensuring the drone's performance and safety in real-world scenarios. Key components of this phase include stress testing, conducting extensive tests to evaluate the drone's capabilities under various operational stresses. Real-world simulations, testing the systems in environments that replicate actual conditions in cinematography, agriculture, and disaster management to ensure functionality and reliability. Phase 4, Deployment and Training. Finally, in Q1 2026, DJI will move into the deployment and training phase. This phase is essential for maximizing the effectiveness of the new technology. It will include official rollout, launching the AI-driven flight systems for widespread use in the targeted sectors. User training, providing comprehensive training sessions for users to ensure they can fully utilize the advanced capabilities of the AI systems. Fostering a smooth transition to the new technology. Use cases. The application of DJI's AI-driven flight systems will have a transformative impact across the 3 sectors. Cinematography. In the cinematography sector, the AI-driven drones will facilitate complex shots while capturing high-quality footage autonomously. This innovation will significantly reduce the need for extensive crew setups and allow filmmakers to achieve creative shots previously deemed too challenging or costly. Agriculture. In agriculture, the autonomous flight systems will enhance precision farming practices. By optimizing crop monitoring and management, these drones will be able to adapt their flight patterns based on real-time data, improving yield and resource efficiency. Disaster management. In disaster management, the drones will play a crucial role in real-time reconnaissance and assessment of disaster-affected areas. By providing timely and accurate data, these systems will aid in rescue operations and logistical planning, ultimately saving lives and resources. Key points. Operational efficiency. All sources emphasize the importance of AI-driven systems in enhancing operational efficiency and safety across the targeted sectors. Strategic investment. the $5 million budget is recognized as a strategic investment to facilitate the successful transition from concept to operational systems. Differences between sources. While the core message remains consistent across various sources, differences emerge in the level of technical detail provided about the AI algorithms and the potential impacts within specific industries. Some sources suggest that unforeseen challenges in R&D may extend the projected timeline for each phase. Timeline of events. Q1 2024, initiation of the R&D phase focusing on algorithm development. Q2 2025, completion of prototype development and commencement of user testing. Q4 2025, final testing and validation of the AI systems. Q1 2026, official rollout of the AI-driven flight systems, accompanied by user training sessions. Conclusion. DJI's initiative to implement AI-driven flight systems represents a comprehensive and strategic approach to enhancing autonomous navigation capabilities across cinematography, agriculture, and disaster management sectors. By following a structured four-phase process and allocating a thoughtful budget, DJI is poised to usher in a new era of drone technology that not only improves operational efficiency but also expands the possibilities for innovation in these critical fields. As the timeline progresses, the successful execution of this plan will depend on continuous engagement with end users and adaptability to emerging challenges. The implementation of DJI's AI-driven flight systems by Q1 2026 is structured into four phases with a budget of $5 million aimed at enhancing autonomous navigation across cinematography, agriculture, and disaster management. Phase 1, Research and Development R&D, involves developing AI algorithms for flight navigation and object recognition, emphasizing adaptability to environmental conditions. This phase utilizes machine learning to build models capable of performing under various operational requirements. Phase 2, Prototyping, focuses on integrating the AI systems into DJI's existing drone technology. User feedback is vital for refining these prototypes, ensuring they address the specific needs of end users in the targeted sectors. Phase 3, Testing and Validation, will conduct rigorous performance tests of the AI systems across diverse scenarios, including stress tests and real-world environments, to ensure reliability and safety. Phase 4, Deployment and Training, centers on rolling out the AI-driven systems and providing necessary training for users in the respective industries to maximize the technology's capabilities. Use cases. In cinematography, AI-driven drones will facilitate complex shots autonomously, reducing the need for large crew setups and capturing high-quality footage. In agriculture, these drones will enhance precision farming by optimizing monitoring and management through autonomous flight patterns adaptable to field conditions. In disaster management, drones will aid real-time reconnaissance and assessment of disaster-impacted areas, delivering critical data for rescue operations and logistical planning. Common key points include the emphasis on operational efficiency and safety improvements in targeted sectors. The $5 million budget is noted as a strategic investment to transition from concept to operational systems successfully. Differences between sources highlight that some provide detailed technical aspects of the AI algorithms while others focus on the potential impacts on specific industries. There is also variation in projected timelines for each phase, with some sources suggesting potential delays due to unforeseen R&D challenges. Timeline of events. Q1 2024, initiation of the R&D phase. Q2 2025, completion of prototypes and start of user testing. Q4 2025, final testing and validation. Q1 2026, official rollout of AI-driven systems with user training sessions. In summary, DJI's initiative is a comprehensive project structured around four critical phases aimed at enhancing autonomous navigation in cinematography, agriculture, and disaster management, supported by a strategic budget and planned timeline for effective deployment and utilization of advanced technologies. Counterintuitive information. 1. Budget allocation. While $5 million may seem substantial, it is relatively modest for the scale and complexity of developing AI-driven flight systems, especially considering the vast potential applications in high-stakes industries like disaster management. 2. Phased approach. The structured four-phase approach implies careful planning and risk management, however. It may also lead to prolonged timelines that could hinder rapid adaptation to fast-evolving technological landscapes or competitive pressures. 3. User feedback. The reliance on user feedback in the prototyping phase suggests that end users may have a significant influence on the final product, which is counterintuitive for a tech-driven initiative where one might expect engineers and developers to dictate the design based on technical specifications. 4. Testing rigorousness. The emphasis on stress testing in real-world environments indicates a proactive approach to safety and reliability, which is often overlooked in many tech projects where limited testing may lead to significant issues post-deployment. 5. Diverse application. The application of the same AI-driven technology across very different sectors, cinematography versus disaster management, suggests a versatility that is often not achievable with specialized technologies, indicating an innovative approach that may defy conventional wisdom about sector-specific solutions. 6. Market readiness. The timeline indicates readiness for deployment by Q1 2026, however, the rapid evolution of technology means that what is cutting-edge today may be outdated by the time of launch, presenting a risk that is often underestimated in tech development projects. 7. Training necessity. While advanced AI systems are typically seen as user-friendly, the emphasis on training suggests a recognition that users may not intuitively grasp the complexities of autonomous systems, challenging the assumption that advanced technology inherently leads to ease of use. The report on the implementation of DJI's AI-driven flight systems by Q1 2026 outlines a significant technological initiative that is likely to have far-reaching implications across various sectors. While the report provides a structured overview of the project phases and use cases, there are crucial insights that many readers may overlook, which are significant for understanding the broader context and potential impacts of this initiative. Overlooked insights. 1. Impact of AI on operational efficiency. The report emphasizes the enhancement of operational efficiency through the implementation of AI-driven systems, particularly in cinematography, agriculture, and disaster management. However, the broader implications of this efficiency gain are often understated. For instance, in cinematography, the ability of drones to autonomously capture complex shots can democratize filmmaking, allowing smaller production companies or independent filmmakers to produce high-quality content without the financial burden of large crews. This shift could fundamentally change the landscape of media production, creating more opportunities for diverse voices and innovative storytelling. 2. Environmental adaptability of AI algorithms. The report mentions the development of AI algorithms that can adapt to varying environmental conditions, but it does not dive deeply into the significance of this adaptability. In agriculture, for instance, the ability to optimize flight patterns based on real-time environmental data can lead to more sustainable farming practices, reducing waste and enhancing crop yield. This aspect is particularly important in the context of global climate change, where adaptive technologies can play a critical role in food security and resource management. 3. User-centric development and feedback loops. While the prototyping phase highlights the importance of user feedback in refining AI systems, the potential for establishing a continuous feedback loop throughout the deployment phase is significant but underexplored. By creating mechanisms for ongoing user input, DJI can ensure that its systems evolve in response to real-world challenges and user needs, thus fostering a community of practice that enhances innovation. This approach can lead to long-term improvements and adaptations that keep pace with technological advancements and shifting industry demands. 4. Collaborative potential across sectors. The report delineates 3 sectors where the technology will be deployed, yet the potential for cross-sector collaboration is not sufficiently addressed. For example, the data collected by drones in disaster management could inform agricultural practices by analyzing the impact of natural disasters on farmland. Similarly, insights gained from cinematography could enhance storytelling around agricultural practices or disaster recovery, leading to richer narratives that engage the public and influence policy. Recognizing and fostering these synergies could amplify the overall impact of the technology. 5. Regulatory and ethical considerations. The implementation of AI-driven flight systems raises important regulatory and ethical questions that are not discussed in the report. As drones become more autonomous, issues related to privacy, airspace regulation, and safety become increasingly relevant. The significance of developing frameworks to address these concerns cannot be overstated, as they will determine the public's acceptance of drone technology. Engaging with policymakers and stakeholders early in the development process could help shape regulations that promote innovation while ensuring public safety and trust. 6. Long-term economic implications. The $5 million budget allocation is mentioned as a strategic investment, but the long-term economic implications of this initiative are not fully explored. The integration of AI-driven systems could lead to job displacement in some sectors, particularly in roles that involve manual piloting or monitoring. Conversely, it may also create new opportunities in AI development, drone maintenance, and data analysis. A comprehensive analysis of these economic shifts, along with strategies for workforce retraining, would be crucial for stakeholders in the affected industries. 7. Public perception and acceptance. The report does not address how public perception of drones and AI technology could impact the success of this initiative. As drones become more prevalent, public fears surrounding safety, privacy, and job loss may influence acceptance. Engaging in proactive communication and education efforts to demystify the technology and highlight its benefits will be essential for fostering a positive public perception and ensuring successful adoption across sectors. Significance of overlooked content. The insights highlighted above are significant for several reasons. Broader implications of technology. Understanding the multifaceted implications of AI-driven technology allows stakeholders to prepare for and adapt to changes that go beyond immediate operational improvements. Innovation through collaboration. Recognizing potential synergies among sectors can lead to innovative solutions that address complex challenges, ultimately enhancing the technology's impact. Proactive engagement. Addressing regulatory, ethical, and public perception issues proactively can prevent backlash and ensure smoother implementation, fostering an environment conducive to technological advancement. Economic forecasting. Anticipating economic shifts and preparing for them can help mitigate negative impacts on the workforce, ensuring that advancements in technology benefit society as a whole. In conclusion, while the report provides a detailed overview of DJI's initiative to implement AI-driven flight systems, the overlooked content provides deeper insights into the potential societal, economic, and regulatory implications of this technology. Recognizing and addressing these aspects will be critical for ensuring that the benefits of AI and autonomous systems are maximized while minimizing potential drawbacks. 1. Phased implementation strategy. The structured approach, comprising 4 distinct phases: research and development, prototyping, testing and validation, and deployment and training, ensures a comprehensive method for integrating AI-driven flight systems. This strategic breakdown allows for progressive refinement and assessment at each stage, which is crucial for addressing potential challenges in technology development and user adoption. 2. Sector-specific use cases. The application of AI-driven flight systems across cinematography, agriculture, and disaster management highlights the versatility and transformative potential of this technology. By enabling autonomous operations tailored to the unique demands of each sector, DJI's initiative can significantly enhance productivity, operational efficiency, and safety, thereby creating substantial value for stakeholders involved in these industries. 3. The budget allocation and resource management. The strategic investment of $5 million is a critical element for the project's success. This financial commitment underpins the research, development, and deployment phases, ensuring that adequate resources are available to tackle the complexities of AI integration. Effective budget management will be essential in balancing innovation with practical execution, especially given the technical challenges anticipated in the R&D phase. For timeline and milestone tracking, the outline timeline with specific milestones from Q1 2024 to Q1 2026 provides a clear framework for monitoring progress. Each phase is time-bound, allowing for the assessment of advancements and adjustments as needed. This timeline is vital for maintaining project momentum and ensuring timely delivery of the AI-driven systems to end users, ultimately supporting DJI's competitive positioning in the autonomous flight market. 1. The Apollo Program 1960s to 1970s. The Apollo program was a series of space missions undertaken by NASA with the goal of landing humans on the Moon and bringing them safely back to Earth. Initiated in the early 1960s, the program involved extensive research and development, including the design of spacecraft rockets and navigation systems capable of handling the complexities of space travel. The program can be broken down into phases: the planning and development of the Saturn V launch vehicle, the testing of the Apollo spacecraft in low Earth orbit, and the execution of lunar missions, culminating in Apollo 11's historic moon landing in 1969. The Apollo program not only advanced human space exploration but also drove technological innovations in various fields, including materials science, telecommunications, and computer technology. 2. The Manhattan Project 1942 to 1946. The Manhattan Project was a secret U.S. government research and development project during World War II that produced the first nuclear weapons. Initiated in response to fears that Nazi Germany would develop atomic bombs, the project involved collaboration between scientists, military personnel, and government officials. The work was divided into several phases: initial research on nuclear fission, the construction of large-scale production facilities, and the testing of the first atomic bomb in New Mexico Trinity test in 1945. The successful development of atomic weapons significantly altered the course of the war and international relations, leading to the bombings of Hiroshima and Nagasaki. The project also had lasting impacts on science, technology, and military strategy. 3. The Human Genome Project 1990 to 2003. The Human Genome Project was an international scientific research initiative aimed at mapping and understanding all the genes of the human species. Launched in 1990, the project involved a collaborative effort among scientists from around the world and was structured in phases: the mapping of the human genome, the sequencing of DNA, and the analysis of genetic data. The project faced numerous challenges and required advancements in technology such as the development of high-throughput sequencing methods. Completed in 2003, the Human Genome Project provided critical insights into genetics, paving the way for advancements in medicine, biotechnology, and personalized healthcare. Its legacy continues to influence research in genomics and the understanding of genetic diseases. Future outlook: predictions for the implementation of DJI's AI-driven flight systems by Q1 2026. As DJI moves forward with the implementation of its AI-driven flight systems, the anticipated outcomes across cinematography, agriculture, and disaster management herald significant advancements in operational efficiency and effectiveness. By Q1 2026, several predictions can be made regarding the impact of this technology in these key sectors. 1. Cinematography, revolutionizing filmmaking techniques. Enhanced creativity. With AI-driven drones, filmmakers will gain unprecedented control over complex shots. The ability to program intricate flight paths and camera angles autonomously will allow for more creative storytelling without the logistical constraints of traditional filming methods. Cost reduction: the need for large film crews will diminish, as fewer personnel will be required for aerial shots. This could lead to reduced costs in film production and democratize access to high-quality filmmaking tools for independent creators. Real-time feedback: filmmakers will benefit from real-time analytics provided by AI systems, allowing for on-the-fly adjustments during shoots, enhancing the overall quality of the footage captured. 2. Agriculture, precision farming, and sustainability. Increased crop yields. The integration of AI-driven drones in agriculture will facilitate precision farming techniques. By analyzing crop health via aerial imagery and adjusting flight paths for optimal monitoring, farmers can expect increased yields and more efficient resource use. Sustainability initiatives. Enhanced data collection and analysis will support sustainable farming practices. Drones can monitor soil conditions and crop health, enabling farmers to minimize pesticide use and optimize water resources. Aligning with global sustainability goals. Real-time data utilization. Farmers will leverage the real-time data provided by drones for immediate decision-making, improving operational responsiveness and reducing waste. 3. Disaster management. Enhanced response capabilities. Rapid assessment. AI-driven drones will significantly improve the speed and accuracy of damage assessments following disasters. First responders will have immediate access to aerial views of affected areas, allowing for better strategic planning and resource allocation. Search and rescue operations. The ability of drones to navigate challenging terrains autonomously will enhance search and rescue efforts, potentially saving lives by providing critical information to emergency teams in real time. Data-driven decision-making. The integration of AI in disaster management will foster a data-driven approach, enabling agencies to predict potential risks and deploy resources more effectively based on the analysis of historical data and real-time conditions. 4. Technological advancements and industry implications. AI and machine learning growth. The successful implementation of DJI's AI-driven systems will likely spur further advancements in AI and machine learning. This could lead to innovations in algorithm development, making drones smarter and more capable of handling complex tasks beyond current specifications. Regulatory changes. As the use of drones in various sectors becomes more prevalent, regulatory bodies may adapt existing laws to accommodate these technologies. This could lead to new certifications and operational guidelines, ensuring safety while promoting innovation. Market expansion. The success of DJI systems may encourage other companies to enter the drone market, leading to increased competition and innovation. This could result in reduced costs for consumers and businesses, further expanding the use of drones across different industries. 5. Challenges and considerations. Technological barriers. While the projected timeline is optimistic, unforeseen challenges in R&D could lead to delays. Technical hurdles in algorithm development or integration with existing systems may require additional resources and time. User adoption. Successful deployment hinges on user acceptance and training. Ensuring that end users are adequately trained to utilize the technology will be crucial to maximizing its potential benefits. Ethical and privacy concerns. The widespread use of drones raises questions about privacy and data security. Addressing these concerns proactively will be essential to gaining public trust and regulatory compliance. Conclusion. The implementation of DJI's AI-driven flight systems by Q1 2026 presents a transformative opportunity across cinematography, agriculture, and disaster management. While the benefits are substantial, the path forward will require careful navigation of technical, regulatory, and ethical challenges. As the project unfolds, stakeholders in each sector must collaborate to leverage these advancements effectively, ensuring that the promise of AI-driven technology is realized while addressing potential concerns. The future of autonomous navigation in these industries is not just a technological evolution but a paradigm shift that could redefine operational standards and practices in the years to come.